We're going to talk about some algorithms for doing multiplication. And we're going to use powers of tens to help us through our multiplication. So if we start off with, let's say 4 times 275, just like before, we can split up this 275 into addition. So it'll be 4 times 200 plus 70 plus 5. But instead of writing 200, I could also just write it as 2 times 10 squared, because 10 squared is 100, plus 7 times 10 plus 5. And then, using distributive property, I'm going to distribute the 4 into each part. Whoops. All right, so if I do that, it's 4 times 2 times 10 squared plus 7 times 10 plus 4 times 5, and I forgot the 4 here, so times 4, right, because the 4 needs to be distributed to each term, so that's a 4 times 7, not a 47. So carrying along, we get 4 times 2 is 8 times 10 squared plus 4 times 7, which is 28 times 10, plus 5 times 4, which is 20. So 8 times 10 squared is just 800. And then 28 times 10 is 280. Oops, 280. And I add 20. So adding it all up, 280 plus 20 is 300, plus 180, or 800, is I messed up, 1100, right? Because it's 300 plus 800, which is 1100. So that's a result of doing it that way. Let's see. So what if we have a 2-digit by a 2-digit? So let's do 25 times 13. So one way to do it is by the area model. So you can do this using the longs and flats and whatnot as well. But 25 is 20 plus 5, and 13 is 10 plus 3. So the numbers that I fill in here are you can consider the area given the length and the width. So you have a 10 times a 20, so we get 200 for here. And up here we have 5 times 10, which is 50. And then here we have 20 times 3, which is 60. And last we have 3 times 5, which is 15. But we were looking for the area of this entire thing. So we just add up 200 plus 60 plus 50 plus 15. Right? So when we add that all up, we get 325. But yet another way to do that is by using the lattice method. So the setup is sort of similar. So it's 13, and it doesn't matter which way you put it. So we do 1, 3, and then it's 25, so I just write 25 as is, right? So that's the difference between the area model and the lattice model. We're just placing it, not saying it's 10 plus 3 necessarily. And then you just do the multiplication. So 3 times 5 is 15. 2 times 3 is just 6. 2 times 1 is just 2. And then 1 times 5 is just 5. Whoops, that should have been a 0. My bad. And then you add up along the diagonal. So I get 5 here. Let's see, 12, so I carry 1 over to the next diagonal, and I get a 3 there, and I have a 0 there. And then you just read it from here to there. So we get 325. So for this one, if the student has trouble with all the place values and whatnot, since you're dividing each part into 2 sections, you can already place whatever is on the next level, so you can worry about carrying things or adding things later on instead of up front.